For this problem, we have an airplane that is 6 miles high and it's flying on a flight path that will take it directly over a radar tracking station. If the distance from the plane to the station S is decreasing at a rate of 400 miles per hour when S is 10 miles, what is the speed of the plane? Okay, now we don't know anything left or right, but that's okay because it says what is the speed. We don't really care about the sign we're going to get at the end of that. So what I need to draw is I have some ground, and I have a plane, and he is flying on a flight path, so I have him headed this way, that will take him directly over a radar tracking station. So I'm going to put my radar tracking station right there. If the distance from the plane to the station S, so this distance, when they ever give you a distance, they're talking about straight line distance, this is S, is decreasing at a rate of 400 miles per hour, so I'm going to say ds dt equals negative 400 miles per hour when S is 10 miles. What is the speed of the plane? Now, other things that we know, I'm going to draw the altitude because it says the plane is 6 miles high, so I'm going to call this just the y value because it's up, down. So I'm going to say y equals 6 miles. Okay, so I need some kind of equation that relates to variables, and this is what it looks like. We have the Pythagorean theorem again. So I need to label this side, and I'm going to give it an x because it's a left-right distance. So my equation will be x squared plus y squared equals s squared. Now I'm going to take my derivative. The derivative of x squared is 2x dx dt plus 2y dy dt equals 2s ds dt. And we're going to fill in what we know and what we don't know. So I need 2 times the x value. I don't know that this second. Dx dt. We have to look at what is dx dt. Okay. X is this distance here. So the rate of change of this will actually give us how fast the plane is going because the plane is moving in that direction. In fact, you could draw it up here. It is the same exact thing, and it might make more sense to you that this is your X right there. How fast this line decreases is how fast the plane is going. So that's what we're actually looking for. Plus 2 times our y value, so 2 times 6. Now we need dy dt. That's the rate of change of this line as time goes on, this distance. Well, the plane is traveling in a horizontal path here, so this distance right here is not changing, so dy dt is actually 0 in this case. 0 miles per hour. The height is not changing. Equals 2 times s is 10, and ds dt is a negative 400 miles per hour. So the only thing I'm missing really here to be able to solve for dx dt is x, and we do have a right triangle, so we can do the Pythagorean theorem. Now I know at this moment that s is 10 and my y is 6. This is also a 3, 4, 5 right triangle. If I divide this by 2, I have 5. Divide this by 2, I have 3. So this one will be 8. Or you can actually do the Pythagorean theorem if it doesn't work out. But I'm going to say that when all of this happened, it was in a horizontal distance 8 miles away. So I could have canceled out the 2's. We talked about that on a previous problem because it's in every term, but I didn't, and I'm just not going to right now. So this is 16 dx dt. This goes to 0 equals 2 times 10 is 20 times a negative 400 is a negative 8,000. Right there. And then to solve for dx dt, I'm going to divide both sides by 16. Is a negative 8,000 over 16, which does go into evenly. And we have 500. So this is a negative 500. But the negative is basically just saying, hey, I had my plane going to the left. I could have drawn it with the radar tracking station over here and I would have gotten a positive. But it says, what is the speed of the plane? So I really don't care about the sign. What I care about is the magnitude. So the plane was going 500 miles per hour.